Hi everyone. Once again, I welcome you all for another beautiful presentation on signals and systems. Right? So far, we have seen various classifications of systems. In our previous presentations, if you recall, we have studied the linear time invariant system as well as linear time variant system, right? And in today's presentation, we will see the next classifications of system, and which is one of the very important, that is causal system and then non-causal system, right? So for any given system, how we can justify or how we can determine that the system is causal or non-causal, right? So let us go into the subject and we will see the definition of a causality of a linear time invariant system, and then thereby we will see few examples on it, how the causality of the system can be justified or can be determined, right? We will go into the subject. What is a causality or what is a causal system, right? What is a causal system? What do you mean by a causality? As far as our subject is concerned, by the way, this is lecture number 40, and we will see the causality of a system in this today's presentation. Right? In order to, in order to study the definition about the causality of a system, let us consider this particular block diagram. Let us say, as I have explained you in our previous presentations, that let us say that it is any given LTI system, means linear time invariant system. It has certain input. Let us say x of t is your input, and then say that y of t is your output, right? X of t is our input and y of t is our output, right? If this particular system, means linear time invariant system, if this particular system is said to be a causal system, clear? If this particular system is said to be a causal system, then the output, this is what the output, this is what your input actually, the output y of t must be, your y of t must depend on present input as well as past input and then past output values, not the future input as well as the future output values. Clear? That is what the definition of a causal system, right? The causal system is nothing but for any given linear time invariant system, if it is said to be a causal system, the output of the system, that is y of t, should depend, it depends on the present input, means x of t. Okay, your output y of t must or shall depends on present input, that is x of t, and then past inputs, maybe x of t minus 1 or otherwise x of t minus 2 and so on and so forth. Past means we will have this kind of terms, x of t minus 1, x of t minus 2, x of t minus 3 and so on and so forth, as well as the past inputs, past outputs, nothing but y of t minus 1, let us say y of t minus 2 and so on and so forth, y of t minus 10 and so on and so forth. These are called the past outputs. Past outputs, t minus 1, t minus 2, t minus something indicates the past values. Therefore, if the y of t is a function of x of t minus 1 or x of t minus 2 or something, whatever it is, that must be x of t minus form it should have, as well as y of t minus 1, t minus 2 or whatever the thing, right? So if our output depends on this type of terms, then you can say that the given system is a causal system, right? On the other hand, if the output of the system y of t depends on future inputs, what? Future inputs. Future inputs nothing but some x of t plus 1, x of t plus 1 as well as x of t plus 2 and so on and so forth. X of t plus. If you have some plus terms, then that is called the future input. Future input as well as the future output means y of t plus 1, y of t plus 2, y of t plus 3 like that. If our output depends on future input as well as the future output values, then that particular system is said to be a non-causal system. Very simple definition. It's a very simple definition, right? Therefore, your output should contains the values of input as well as the output must be the present as well as the past values only. Present and past values only, but not the future values for a causal system, right? So that is what the basic definition of a causal system. And moreover, there is one very important condition that need to be remember for causality of a system in terms of its impulse response. In terms of its impulse response, it is a very important bit to note down, or it is very important point to remember. Let us say, for example, this is the given LTI system. Let us say LTI system, clear? As I already explained just now, x of t is your input and y of t is your output, let us say, clear? These are in terms of the time domain. Your x of t is a time domain input as well as your output is also in time domain, and the correspondingly what is the function or what is the transfer function or system function, or otherwise I can explain you that, let us say the frequency content of x of t is x of omega. This is the frequency domain or frequency content, you can say. It is x of t is the time domain representation, whereas correspondingly x of omega is its frequency representation, as well as for y of t, what is the frequency representation? It is capital Y of omega. If you know the input and outputs in terms of their frequency representations, obviously here the system will have the transfer function or system function sometimes, that is what your h of omega. Clear? This already we have discussed in our earlier presentations. Therefore, h of omega is nothing but the transfer function of the system, and that is represented by this. So this is the frequency representation of your transfer function. Say for example, correspondingly, what could be the time domain representation of h of omega? It is nothing but h of t. Remember that. H of t is the time domain representation of your h of omega. Clear? So x of t has x of omega and y of t has its y of omega, then definitely your h of t, so the impulse response of the system is nothing but h of t, and if you take the frequency response of it, then it definitely h of omega. Right? What is h of t? Here called it as impulse response. So this h of t is called as impulse response. Clear? Impulse response. So your h of t is called as impulse response. Right? And here very important point to note down is that for causal system, note down this, right? For causal system, the impulse response, clear? What is that? The impulse response, that is h of t, is equal to 0 for t is less than 0. This is the very important condition that need to be remembered. The impulse response means h of t value becomes 0 for t is less than 0. for t is less than 0. It means that, so before the application of the input, what is t is less than 0? Means we have not at all applied any input. So before the application of the input, your impulse response of the system must be 0. In fact, if you do not give any input, obviously the system should not give any output in general. But sometimes, depending on some previous values or previous information, the system may be produced the output, right? Depending on the condition and depending on the previous information. But don't worry, as far as our topic is concerned, as far as the causality of the system is concerned, remember this point only. So your impulse response must be 0. H of t must be 0 when for t is less than 0. For t is less than 0. If this condition satisfies, then the system is called a causal system, and it is very, very important point. This point is very important point, right? So this is what about the causality. Therefore, in terms of the input and output, you can give the definition as my output y of t should depends at any instant of time t on the present value of input as well as the past inputs and then past outputs only. Means the output y of t depends on present input, okay, and then past inputs as well as the past output values, but not on future input and also future output. It should not depend on future input values as well as future output values. It should not depend on future values. It must depend, the output must depend on present and past values only. Otherwise, you remember like this. The output should depend on present input as well as the past input, past output values only. Past values only, not future values. This is what the simple definition of a causal system, right? So, shall we see one example on this so that you can understood this concept in a very clear manner. This is what the definition basically. Now I will explain you some examples so that you will understand better, right? So let us take one example basically. Let us take one example. So let us take the example. It is example 1. Example 1. Let us say y of t. The output is given as y of t is equal to x of t minus x of t minus 1. X of t minus 1. Clear? X of t minus x of t minus 1 is the system causal or non-causal? This is the question. Now, how we can solve this? This is the given system actually. So, this is the output of a system. Y of t is equal to x of t and then x of t minus 1. This is the expression form of the output in terms of the inputs, right? And by simply observing it, you can say that your output y of t, actually your output x of t is the present input. What is x of t minus 1? It is a past input. It is the present input. This is the past input. So it does not have any future values like x of t plus 1 or y of t plus 1 like that. Future values are not there. So this is the present. This is the present output. Y of t is called as the present output. X of t is called as present input. Therefore, the present output depends on the present input as well as the past values, past input. Therefore, this system definitely it is a causal system. This is a causal system, directly you can say. It is a causal system, right? Why? Because the present output depends on the present input as well as the past input. It is depending on present values and then past values. Okay, so there is no future component here, right? Therefore, it is a causal system. This is an example for causal system, right? So similarly, shall we do one more example? Let us see one more example. Example number 2. Example number 2. Let us see the another example for your better understanding. Example 2. It is y of t is equal to, what is the problem? Y of t is equal to x of t plus what is there? Some 2 times x of, it is given as 3 minus t. Is it causal? Is it causal or not? Is it causal or not? How to solve this? Actually, by simply seeing you can tell, but for few questions or some of the questions you can't directly. So then sometimes what we need to do, so we are checking this particular given system for its causality. What is the causality? What is the condition to be satisfied by the system? It must depend on the present and then past values. Present. So what are the present? Present is nothing but you substitute at t equal to 0. So you substitute different values of t actually. You consider t equal to 0 first. Sometimes you can check the causality like this also. For t equal to 0, what will be your output? So y of 0 is equal to what? Similarly, substitute t is equal to say minus 1. This is past value actually. So then y of minus 1 becomes what? And give one future value also. Let us t of 1, what will be? This is the like that. Clear? Plus 1 like that. Let us say t equal to 0. What will happen t equal to 0? If t equal to 0, what will happen? What will happen? T equal to 0, then it becomes y of 0, right? If t equal to 0, then y of t becomes y of 0, that is equal to x of 0 plus 2 times x of t, value is 0. Therefore, x of 3. For t equal to 0, for this condition, your output y of t becomes y of 0 is equal to x of 0 2 times x of 3 minus 0. So t becomes 0, therefore x of 3. That is for t equal to 0. Similarly, give minus 1. If you substitute minus 1, then x of minus 1 gives that x of minus 1 means t is minus 1 plus 2 times x of 3 minus, it is minus 1. This equal to, further if you simplify this, x of minus 1 plus 2 times x of 3 minus into minus plus 1. Therefore, 3 plus 1, it is x of 4. So, therefore, at t equal to 0, you substitute, if you observe at t equal to 0, your output y of 0 becomes x of 0 plus 2 of x of 3. What is x of, okay, enough. You can substitute either 1, 2 values are enough. Not required to check for more values. No, not required. You can check either 1 or 2 values are enough. So, at t equal to 0, your y of 0 becomes what? X of 0. So, x of 0 means present input. So, y of 0 means present output. So, present output is equal to your present input. What is x of 3? It is not present, it is future. It is future. It is future input actually. If it is past, then definitely it must have some x of minus 1, x of minus 2, x of minus 3 form. Right? This is the present actually. X of 0 is the present input value. Whereas if it is past, if so, it must have x of minus 1, minus 2, minus 3, x of minus 3. But it is having now x of 3 means plus 3 actually. Means it is a future input. There obviously, what is the causality condition? So, the output must depend on present input and then past inputs only. Whereas this x of 3 is a future input. Therefore, future input, right? Okay. Now, coming to the second condition, at t equal to minus 1 means past input. This is past. Therefore, for t equal to minus 1, your minus 1 is equal to, y of minus 1 is equal to x of minus 1. So, y of minus 1 is the, let us say, present. You can say present output at t equal to minus 1. So, x of minus 1 is exactly the input at t equal to minus 1. But what happens here? It is x of minus 1 and then x of 4. If you simplify here, it is giving x of 4. Again, what is this x of 4? It is the future actually. It is the future input. It is the future input. Therefore, by observing these two conditions at two different time intervals we have taken, so it is consisting of the future input values. Therefore, as it is having the future input, then definitely this system is a non-causal system. It is not causal. It is not causal. It is a non-causal system. It is a non-causal. It is not a causal system. It is non-causal system, you can say. Clear? I think you understood very well this, and I think I will finish off this presentation here, and we will continue with some more examples in our next subsequent presentations, right? Thank you for watching this presentation, and if you have any doubts and then comments, you can post on my channel, and I definitely will go through it, and I definitely will address, and I will try to give the better and best solutions for all your queries and all these things, right? Have a good day.